Okay, so this is what we got set up. The battery goes in here. I'm going to take this cover off the controller so that I can get at these switches a little easier. So we got just normal receiver, battery, and channel 5 output from the receiver for Futaba is the gear. 2 cables. And these are my, my engineering cables, so to speak. They would be different in the airplane, unless I happen to look out, of course, and these are the right length. But they would be, built to the length needed in the airplane. And, the 2 mechanisms here, pretty simple. Here I forgot to cut the rod off. Here I did cut the rod off. I got a plywood trunnion here, made of multiple layers of plywood, a coupler and a motor with an encoder, and this is 3D printed. This houses the current sensor. These 2 guys right here, and it's a pretty simple mechanism. Just like a standard air retract, except it's being powered by a motor. Pushes the, I don't even know what you call this thing, the pin. What do you call that? I do know what it's called, but I forget. But anyway, works pretty much like a standard retract. This set I made trimmable in the retracted position. In the program I can actually trim where it stops so that the gear is tucked up inside the airplane at the proper depth, so that they're not hanging out. I show there's a slot here that it would lock into, but that may not be where it needs to be. So that's the nice thing about using an encoder, is that you can actually digitally position the trunnion wherever you want it. So anyway, that's it, and of course I got a transmitter here. And so now we'll begin. Go off a little bit. Before I begin, I'm going to show you that the retracts in this, this is a mock-up first off, it's made of foam, but the gear rails in the Spitfire, Reeves Spitfire, it had a crazy angle there, as you can see, and so when you look at these retracts here mounted on the end of this workbench, that's why the struts look like they're at a weird angle, but everything works out when let's get this in view here. Everything works out when they're installed in the wing. So maybe you can't tell, but these are a mock-up. Everything's a mock-up here. I began, you can see the frame of the body, I extended it. I began with a motor that had no encoder, and later on I changed to a motor that does have a positional encoder, and so I had to extend the body. Of course, that won't be in the original or in the final item. Also, of course, you can see I've got wooden struts here. Okay. The purpose of this right now is to test the controller, and of course to see if the motors are up to moving the gear fully loaded. So let's see what we've got here. Some power on this thing. Turn transmitter on. Put the receiver in. And we're ready to go. And I should say this has 3 modes, four modes of operation for retract. Right now I have it programmed for no staggered delay. In other words, both gear are going to go up at the same time. And likewise, they go down at the same time. And I have a program switch in here that will allow one to lead the other. I forget which way it goes now, but we'll see. Oh, by the way, this on the left is the starboard, and that is the port. And this would be as though we were looking at the nose of the airplane, or from the nose of the airplane towards the tail. So that's the starboard leading the port. Starboard leads the port. And of course, I got a mode that's the opposite of that. Okay. That's the port leads to starboard. Yeah. Shit happens, right? None of this stuff is glued together, it's all friction. One more mode here, and that's random. And that's potluck. Whatever comes up, it comes up. And that's starboard leads port. Starboard leads port. Sometimes it repeats. It's port leads starboard. Port leads starboard. Starboard leads port. Port leads starboard. And no stagger. So that's all the possible selections of stagger when it's in a random mode. So it's just gone through all of them. And what else is there? There's not much else to say other than the reason I used, it's up to this beep tape probably, my transmitter batteries getting low. The reason why I use the encoded output is because stalling motors is like antithetical to my profession. You know, I'm an engineer and I don't believe in stalling motors. It works, and you know, I'm not knocking anybody that uses that, but I don't like slamming a motor up against a stop and then stalling it, except I do. And there's one more mode I didn't show you, and that's this mode where you can have an emergency reverse, and that is where I do use the current monitors. But ever it's reversed midway, it no longer uses the encoders, it uses the current sensors. Right now, if I let it go to the end, it used the encoder. And it will always use the encoder unless you reverse the gear. Sometimes it will use the current monitors if it's in an odd place when you first power on. During the day, you might see the gear, it might move a little bit and then lock. It would have used the current sensors to find home, so to speak, and then from that point on out, you know, they're going to use the encoders. But I guess I covered it all. There's one other mode I have where if you accidentally turn the transmitter switch on after you power everything up and the gear's extended and it's on the ground, if you accidentally power everything up with the switch, the transmitter switch in the wrong position, it will set an alarm off. It also will lock the gear up. It won't let you move them until you put the switch back in the correct position. I have no way of showing you that now. because you can't hear that alarm, but it does lock the whole system up. It won't allow you to move the gear unless you put the switch back in the right position. Okay, that's about it.